G'day. Nothing too exciting today. We're just programming, assembling and testing some of these Joey64s, heading off to our friends over at HighScoreTechSupply. I think we've got about 80 of these to do today. And then we'll get on to the Game Gear IPS and a few other bits and pieces that they've asked on this next shipment. So as far as assembly goes, we just need to solder on these controller ports, and that's fairly easy. They are quite large metal pins here, which take a while to get some heat into them to flow, but it's not too bad. And then we test the boards. We use, I'll have to find it. We use Super Mario Brothers 64. Where is it? I'll find it. Yeah, so we use that because it uses EEPROM as a save type, and the controller itself, as well as the memory pack and everything else, all use the same protocol for EEPROM saves. So if the Joey detects an EEPROM save in a cart, we know that the controller will also work because it's the same protocol and goes to the same pin. Alright, so we'll start with flashing the firmware. And there are a few variants with the microcontroller used on these. These ones in particular, 103 RET6. So I'll make sure to select the RET6 firmware. And we're ready to go. So it's flashing, doing a full readback and a checksum, and if it passes we go to the next one. If it fails, we put it aside. The failure rate of these boards from the factory has been around about 3 or 4 units per 100, which isn't too bad. Joey Juniors, after saying that, there we go. Joey Juniors are around about 1 failure per 100. And MBC3K carts, I think the highest we got is around about 40 out of 100 failures. And there's reasons for that. PCBWay blamed the IC supplier, the IC supplier blamed PCBWay. At the end of the day, doesn't really matter. They arrived defective, so they all went into a big box. And if we ever get some spare time, we can look through fixing those, or we could just sell them as 4 parts. They've still got really good quality FRAM, genuine FRAM, which is about, I think, $12 or $13 a piece on Mouser. We buy it in bulk in the 1,000 unit quantities, so we get it quite cheap. So if anyone's after FRAM or flash, yeah, we can sell those in the store. You could pop those chips straight onto a bootleg cart and turn it into a FRAM batteryless cart. I think the rain's back. We had a cyclone come through. I think it landed on shore maybe a day or 2 ago, and we're about 500 k's south of where it landed, and we've had just non-stop rain pretty much since it arrived. Last night was pretty bad. Our roof was leaking in the house, so I need to go on the roof and find out why and patch that up. But yeah, it sounds like it's set in again for the day. Something else we check when we program these, the pins in these cart sockets. These are manually inserted by someone over at the factory. It's not robotic, and if they miss a pin and they force the connector in, you'll see the pin itself shoot up out of the socket. They still work fine, it just doesn't look too good. So what we do there is we reheat the pin and we push the pin back down so it's all flush. All these look to be fine. And something else we check is the USB-C socket. They are located and soldered in, but again, this is robotic and sometimes it's not quite right and it can be lifted. And in cases like that, we will reheat and reflow and make sure everything's working fine. But if they are not soldered correctly, they just won't work, so that's another giveaway. And everything that leaves my desk is fully tested, so you know it's going to work when it arrives to you. Okay, so they're all programmed now. We can go straight into soldering these on, and then we can test it, or we can test it before we solder them on. No huge difference. These would be wasted if the board doesn't work, but these are about, I think, $1 each we pay, so it's not too bad considering. we'll get started. Are we in shot? Yeah, we are. Due to the large heat sink of these pins and the big ground pour, I'll just turn the temp up. So we're at 260 degrees Celsius, which is way hotter than it should be for soldering. It's like generic work, but due to the size of this, it absorbs a lot of the heat. And yeah, a bit of extra temperature here helps. I do have a 300 watt iron, which would be ideal for this, but it's a bit clumsy to use, and there's no temperature regulation. Okay, and also we need to hold the board horizontal, otherwise our controller port gets all wonky. So once that pin's cool, we can then maneuver it how we want, and it's not gonna warp or bend or flex. We could get the factory to do this too, but I suspect if they're doing it manually, they might not have the attention to detail and have it a little bit crooked, which would just be more work for us to correct that. Yeah, so I figured if we do it ourselves, we know it's done right. And there's nothing worse than something being slightly off and looking at it every day. At least to me. I'm sure some people don't care. So you can usually tell when something's not quite soldered right. There should be a nice fillet where it goes from the PCB to the pin, and this one here stands out straight away. It's like a little donut instead of a fillet. So we'll just reflow this pin here. A lot of these pins aren't actually used on a 64 connector, which is surprising. Oops, it's hard to say. Yeah, there's no trace going to this pin, but just to be sure, we'll give it a quick touch up. And there's another one that's not quite right, so we'll reflow that too. And if you're wondering why we don't use flux, there is actually a lot of flux in normal solder. This is from RS, 2.2% flux, which is about average, and that's more than enough for your general soldering work. And when we touch up these pins, for example, we add a little bit more solder to use the flux and help everything wet and reflow. So yeah, smashing flux all over a PCB is not required. Some things it is, like for ICs, flux definitely helps clean oxides and helps everything reflow a little bit. But for general soldering through hole stuff, you don't need to add flux. And we've got 3 more after this one, and then we can start testing. Testing is usually insert the cart, connect the USB, the drive will open, and then we can check debug.txt. And that'll tell us if there is any issues reading the checksum versus the calculated checksum. And the calculated checksum, it reads the first, I don't know, half a megabyte or so from the cart and does some math with that. So if any of these pins aren't correct, checksum will fail, and then we know right away something's not right. Same with the controller port protocol and the EEPROM. If we don't see EEPROM detected, we know there's a problem with either, it could be a short between the ground or positive and the EEPROM signal, or the pin that goes to the EEPROM in the cart. But yeah, we'll know that fails, and then we can go from there. usually we just put it aside. It can take some time to fault find. It could be one of the pins on the microcontroller, the cart, a bad pin, or soldering. So we just put it aside and keep going without it, and we revisit it later when we've got a bit of time. This has been going for 25 minutes. So it'll be about 30 minutes for 20 units, and then extra time for testing. And if all that's good, we package it and move on to the next 20. I think Kyle wanted 60, but I'll double check that. So these should be done today. We'll do our GGHDs, and then I'll drive into DHL, which is a 2.5 to 3 hour return trip, and get that shipped. And they should be with him in about 3 days, which is pretty good from Australia to the US. And we've also got LCDs to ship off to K Retro. And they are our Lynx IPS kits. They've been waiting on screens for a while. They've been delayed and delayed, but they're finally here. So we'll get those shipped off as well. Alright, now we'll find this cart and then we'll get into the testing. I've got a bootleg Stadium here, but that's flash, so it's not really ideal. Oh, there he is. This is, I think, one of the carts from my childhood, so it's pretty worn, pretty used. Definitely needs a clean. This hasn't been cleaned in a long time. But this is what we use to test every single Joey, and I reckon it'll be good enough for this. So, card in, USB. Now, I'm not sure why. Usually the drive would pop up with auto run. It doesn't do it anymore in this laptop, and I've checked everything in registry, I've done everything, and it just doesn't work. So we have to do it manually, which adds quite a bit of time. Yep, supermario.eep, so it detected the file name and it detected the EEPROM save, which is a good sign. An 8 megabyte ROM, also good. And in debug, it knows it's genuine, not a bootleg, and it knows it's a 512 byte or 4 kilobit EEPROM, and the file name's correct. So everything looks good. We'll go ahead and do this for the other 19, and then we'll go on to our next batch. Yeah, I might save you the monotonous repetition and cut it off here, but that's basically how we program, assemble, and test our current batch of Joeys. We used to solder on this connector, and I think we're going to go back to that as well, and also use our pick and place machine to assemble the boards. Our reason for that is import tariffs into the US. There needs to be a certain percentage of assembly done in Australia and not China to be classified as Australian made, and that's going to save, I don't know, 25% or something importing into the US. So yep, that's where we're at, and I'll see you on the next one.